Today, I am going to deal with the physics theory paper of class 12, which was held on 2025. This is recently the physics question paper, the CBSE or CBSE. CBSE. This is a question paper. I'm going to deal with the physics theory for class 12. This is 2025. This was recently held CBSE. So here I'm going to deal with only there were 33 questions, round about 33 questions, but I'm going to solve only the conceptual questions, only the conceptual questions I'm going to solve it. So here, see, a wire of resistance R connected to an ideal battery consumes a power P if the wire is gradually stretched to double its initial length and connected across the same battery, the power consumed. So here you see that power is equal to V square by R, and R is equal to rho L by A. So now here your length is doubled, so R dash will be rho twice L and your area will become half. Because the length is double, so area will become half. So this will be rho 4L by A. Now your R, so here your R dash, we can, so my new power P dash will be V square by R dash, because your same battery, so same by connected to the same battery, so your V is a constant. So now your P dash by P is equal to V square. This will be 4 times R. So this is V square by P dash, that V square by 4R, and your P is equal to V square by R. So this will becomes P dash by P is equal to 1 by 4. So P dash will be P by 4. This is your answer. So this is a very simple question. This was the first question. A wire of resistance R connected to an ideal battery consumes a power P if the wire is gradually stretched to double its initial length and connected across the same battery. The power consumed will be, this is P is equal to V square by R. So P dash is equal to V square by R dash. Now since the length is double, so area will be half. So R dash will be 4 times R. So we are going to get rid of this relation. So this is your answer. My next question is, a vertical held bar is dropped along the axis of a copper ring having a cut. The acceleration of the following magnet is. Now here you see that electromagnetic induction, electromagnetic induction, electromagnetic induction, magnetic induction. This electromagnetic induction, this is only when there is a closed loop and your bar magnet, and as this closed loop, this must be a closed loop, and this closed loop must pass through this this bar magnet must pass through this closed loop, then only current will flow through this loop, then only current will flow through this loop, when that means an induced EMF is produced. But when there is a cut, in the coil, there is no current, no current flows through the coil, no current flows through the coil. No current flows through the coil. That means there is no induced EMF. No induced EMF. There is no induced EMF. That means there is no Lange's law. No Lange's law. There is no Lange's law. So there is no opposing force. So the bar magnet, the acceleration of the bar magnet will be G. So the acceleration of the bar magnet will be G. So the acceleration of the bar magnet, so the acceleration of the bar magnet will be G. Now here a straight conductor is carrying a current of 2 amperes in positive x direction along it a uniform magnetic field is in y and z axis is switched on in the region the force acting on a 10 centimeter length of a conductor. So here F is equal to I L cross B. So now your L cross B, your L length is 10 centimeter, that means 0.1 in positive x direction, that is I cap, and your B vector, that is 0.6 j cap plus 0.8 k cap. So L cross B, this will be determinant method. So I cap, j cap, k cap, 0.1 0 0 0.6, this will be 0 0.6 0.8. So here this will be I cap here, this and this moves, so this 0 minus 0, now minus j cap, this and this 0.08, this and this j, this and this removes, so 8 minus 0, and your k cap will be this, and this goes out, so this is this and this goes out, so this will be 0.06 minus 0. So here this will be equal to minus 0.08 j cap plus 0.06 k cap. So your F will be equal to I, that is 2 minus 0.08 j cap plus 0.06 k cap. So this comes out to be minus 0.16 I j cap plus 0.12 k cap. 6 to the 12, 18. So this is your answer. So one thing you must remember while calculating, that is I cross B. So your I must be first, then your B. If you give B first, then I, then your answer will be changed. Your answer, this will become plus and this will minus. So ultimately your answer, this will be plus and this will be minus, and your whole answer will become wrong. So keep in mind, L cross B, this is the very important point. L cross B force is I L cross B, L vector plus cross B vector. So here since I is first, L is first, so first your line will be L and then B, then only you are going to get the correct answer. Now my next question is, two coherent waves each of intensity I0 produces a interference pattern on a screen, the average intensity of light on the screen. So you know that the intensity at a point, I1 plus I2 plus 2 root over I1 into I2 cos phi, you know this, but because two coherent sources having the same intensity or intensity is the same, so I will be equal to 2 I naught plus 2 root over I naught square cos phi. So this will be I will be equal to 2 I naught plus 2 I naught root over cos phi. So you have to find the average intensity. So I max will be when cos is equal to 0. So I max will be equal to 0, that is 2 I naught plus 2 I naught, that will be equal to 4 I naught, and your I is max minimum when your phi is pi 180 degree. When phi is 0, then it is maximum when phi is your pi, then uh, cos phi root over cos phi, uh, cos 1 minute cos phi, that means I square cos phi, that it comes out to be 2I cos phi, it is 0, it is 0 here. This is cos phi, so and minimum when it is pi, that is 180 degrees, so this will be uh, 2 I naught minus 2 I naught, so this will come to 0. So I average will be equal to I max plus I minimum by 2. So this will be 4 I naught by 2, that will be 2 I naught. So this is your answer. This is your formula, intensity at a point, uh, I1 plus I2 plus 2 root I1 into I2 cos phi. So because they are coherent sources and it is given to you that of same intensity, so I naught, so maximum when phi is equal to 0 and minimum when phi is equal to pi. Now this is your answer. So my next question is n resistors where each of are in series. This is a very easy question. Rs, that is equal for n resistor, it will be Nr, and Rp, that will be equal to R by M. Now you have to find the Rs minus Rp, so this will be Nr minus R by N. So this comes out to be R common n square minus 1 by N. So this is your answer. Now a galvanometer can be converted to an emitter of desired end by connecting small resistance in parallel. A small resistance, a small resistance, a small resistance in parallel, a small resistance in parallel. Inside a nucleus, the nuclear force between proton, neutron, and proton and neutron are, means what is the relation, you have to say this. So inside the nucleus, this nuclear force, this is the same for all cases. Is equal to PF, F, Pn is equal to F and N. It is the same. Now, second, the de Broglie wavelength associated with energy 5 electron volts. So here, de Broglie wavelength, that is lambda, is equal to that is equal to h by p, where h it is the Planck constant, and p is the momentum of the particle, and this, and your P is equal to root over 2 me. It is the energy. So here I have done the calculation. I am going to just replace here the, because it is a very lengthy calculation. So this is the formula used where lambda is equal to h by p, Planck constant, by momentum of the particle, and the momentum of the particle is 2 me, where E is the energy, that is energy it is given to you, where E it is equal to 5 electron volt. I am just going to calculate it from for you. So here your mass, this mass of the electron, that is equal to 9.11 into 10 to the power of minus 31 kg, and your E, this is equal to 5 into 1.602 into 10 to the power of minus 19 joules. So this comes out to be 8.01 into 10 to the power of minus 19 joules. Now when you place the value of me, your P is going to be, you will get P is equal to 1.20 into 10 to the power of minus 24 kg meter per second, and your lambda will become out to be, and your lambda, that will be comes out to Planck's constant, that is equal to 6.626 into 10 to the power of minus 24, and your P is 1.208 into 10 to the power of minus this is a Planck constant, minus 34, and this is minus 24. So your lambda, it comes out to be 5.486 into 10 to the power of minus 10 meter. So this is will come out to be 0.55 nanometer. So this is your answer. I have calculated this, so I have just placed the data here, because this are big numbers, so I have just calculated for you. Next question is a piece of diamagnetic material free to move when placed in a uniform field. The diamagnetic material does not move because there is no net force. There is no net force on the diamagnet. So because there is no net force, because there is no net force, so your net force, so the diamagnetic material, the diamagnetic material, diamagnetic material, it does not move. It does not move. It does not move. Now you have to calculate the momentum of a proton of frequency this hertz. So here you know there the two formula, E is equal to h into frequency, and your momentum P, that is equal to E by c. C is the velocity of the light. Now I will just calculate it for you. Here your E will be equal to, that is h, that is Planck's constant, 6.626 into 10 to the power of minus 34, and frequency it is given to you as 6.0 into 10 to the power of 14, which comes out to be 3.9756 into 10 to the power of minus 19 joules, and your momentum P, that will be equal to, this energy is 3.9756 into 10 to the power of minus 19 divided by C, that is 3 into 10 to the power of 8 meter per second. So this comes out to be 1.325 into 10 to the power of minus 27 kg meter per second. So this is your answer. Here for dynamic there is no need for, so dynamic means does not move, and the momentum. These are the two formulas used, and I have calculated it. Now this is a very simple question. An AC source is connected to a resistor and inductor are 8 volt and 6 volt respectively. In series they are an AC source is connected to a resistor and inductor are 8 volt and 6 volt respectively. So your voltage V, this will be equal to root over VR square plus VL square. So this comes out to be 8 square plus 6 square. So this comes out to be 64 plus 36. So this is equal to root 100. So this will be equal to 10 volt. Now here a proton and an alpha particle enter with same velocity v in a uniform magnetic field B such that V is perpendicular to B. The ratio of the radii of their path is. So here you know that is the centripetal force, that is mv square by r is equal to q v cross b. So v and b are perpendicular, so this will be q vb sine 90 degree. So this comes out to be qvb. This will be qvb. So here your r will be equal to mv by qb. This will be your r. Now next my here your alpha particles, that is helium nucleus particle, that is helium nucleus He42, this is a helium nucleus. So mass of the helium, that will be 2 proton plus 2 neutron. So let us take this as 4 let me take this as 4m. Let me take this as 4m because there are 2 proton and 2 neutrons, so let it be 4m, and here proton, this is m. So your rp, this will be m, 4m into v by, and q, that is helium nucleus, that is 2 plus, that means 2 proton, that means 2e b, and this is alpha, r alpha, and rp, that will be mv by eb. So your proton and alpha, a proton and an alpha, so your rp by r alpha, when you divide it, this will be 2 mv by eb. When you divide this, rp, this is above, and r alpha, you are going to get 1 by 2. Assertion: a hole is an apparent free particle with effective positive charges. Apparent free particles with effective positive charge, positive electronic charges. A hole. Your assertion is assertion is true. Here your assertion is true. Because holes are created when the electron moves from the valency band to, when it moves from the valency band to the conduction band. Hole is created when an electron moves from the valency band to the conduction band. So apparent free particles are effective positive electron charge. This is true, and your reason is false. Why? Because hole is not necessarily vacant, left behind an electron in valence band. Means holes can also be created by doping. So it is not necessary that is by an electron in the valence band. It can also be created by doping. So reason is false. And here a reflecting telescope, in a reflect, the image does not have a chromatic aberration. Here your assertion is true. Assertion is true. Assertion is true because reflecting telescope uses a mirror. Uses a mirror. Reflecting telescope uses a mirror, and chromatic aberration is possible in a lens. Chromatic aberration is possible in lens, so this is your assertion is true. And occurs only to the refraction. Yes, your reason is also true, because is true because your chromatic aberration, that is dispersion, it occurs only in lens, so your reason is also true. Your assertion is false. Here your assertion is false, because assertion is false because X-ray are produced by not slow moving electron, not slow. It is produced by high energy electrons. It is produced by high energy electrons. It is produced by high energy electrons. It is produced by high energy electrons accelerated by high voltage, accelerated by high voltage. So your assertion is false, and your reason is also false. Reasons is also false because it is not low energy photon. It is not low energy photon. It is high energy photon. High energy photon. So your both are false. High energy photons. So your both are false. A cell of EMF E and internal resistance R is connected to an external variable resistance R. That means a cell, this internal resistance, is connected to a this is connected to a resistance, external variable resistance R. Here this is connected. This is R, this is capital R, and this is epsilon. Plot a graph showing the variation of terminal voltage V of the cell as a function of I supplied by the cell. Explain how EMF of the cell and its internal resistance can be formed. So here we are going to get three type of equation. I is equal to epsilon R by R, R plus R. And next is your V is equal to IR. So this will be epsilon R by R plus R. And your third equation, that is V is equal to epsilon minus IR. So we have to draw a graph. So what conclusion are you going to get? If your I is 0, say from here, if your I is equal to 0, then V is equal to E epsilon. Again, that means I is 0, that means R is your here, from here, your R is infinity. This means R is your infinity. So I will be 0. So R is infinity. Then only R will be 0, R will be infinity. Now, now, if your this is case 1, now if your R is 0, what will happen? I will be equal to epsilon by R, and when I is equal to epsilon by R, then your V will be equal to 0. This is case 2. This is the case 2. So from here, one you are going to get when two relations, when two cases, when case 1, when I is your 0, then V is equal to E. That means your R is infinity. And when your R is your 0, then I is equal to E by R. That means your E by R you place here, E by R. So your V is your 0. 0. So here, from here you plot the graph. Here you just plot the graph. This is I and this is V. So when your I is 0, when I is 0, it is E, epsilon. And when your V is, when your I is I, here I is equal to epsilon by R, then your V is 0. Now you join this. Yes. This is your graph, linear graph. Here you find that, from here you find that your voltage decreases linearly as current I increases. From here you get a conclusion that your voltage decreases linearly when I increases. This is because of the potential drop, IR. This is because of potential drop, that is IR. So here you find that your V decreases linearly with I. So this with I. Now here this is the graph. Now you have to find how EMF of the cell and its internal resistance can be found. So EMF when I is equal to 0, then your V is equal to E epsilon, that is EMF. And to find R, that is you have to take this 10 minus theta slope, because negative minus theta, that is equal to V by I. So V by I, that means this will be epsilon by I, um, epsilon by R, and this will give you the internal resistance R. This will give you the internal resistance R. Slope, the negative of this slope, that means negative of this slope, negative slope, negative slope will give you uh, negative slope will give you that is, and it will give you is equal to internal resistance R. The negative slope will give you the internal resistance R, because you can see here when R is your 0, when R is your 0, so from here R is equal to epsilon by I. This, when your R is 0, epsilon by I, that is your negative slope will give you the R, and you can find out the EMF of the cell, that is when I is equal to 0, your EMF will be V is equal to epsilon, that is EMF, and negative of this slope, because we are taking in anti-clockwise direction, so negative slope will give you the R. I think so it is clear here. So this is how you can, this is the graph, and this is how you can find the EMF of the cell and internal resistance. Because R is 0, when R is 0, then your V is 0, and then when V is 0, then only you can find out internal resistance. R is 0, that means at that time your V is 0. Only then only you can find the internal resistance, that is epsilon by I.